Hello.
Good afternoon, sir.
Hello.
Sir.
Voice.
వినిపిస్తుంది సార్.
Okay. ఓకే. స్క్రీన్ కనిపిస్తుందమ్మా? హలో.
No, sir.
No, sir.
కొంచెం టైం పడుతుంది చూడండి. నెట్ స్లోగా ఉంది ఇంట్లో. రాలేదా? స్క్రీన్ కనిపించట్లేదా?
ఇప్పుడు వచ్చింది సార్.
కనిపిస్తుంది. Discuss about design and management of urban drainage system. It's mostly theory part, right? It is very general in nature, and everyone, most of you also know. What type of work generally these municipal people will do. నాకు తెలియదు కదా. ఓకే. ఓకేనమ్మా?
సార్ వాయిస్ బ్రేక్ అయిపోయింది సార్, వినిపించలేదు సార్.
హలో.
సార్
హలో.
Sir.
అందుకే చెప్తున్నాను, నాకు వెంటనే మీరు ఇన్ఫార్మ్ చేయండి అంటున్నాను. ఫోన్ ద్వారా చేయండి.
ఓకే సార్.
హలో.
సార్ ఇన్ఫార్మ్
మీ
చేస్తా.
వాయిస్
చెప్పమ్మా.
వాయిస్ బ్రేక్ అవుతుంది సార్.
కదా నా వాయిస్? క్లారిటీ లేదమ్మా. బ్రేక్ అవుతుందా?
అవును సార్, బ్రేక్ అవుతుంది వాయిస్.
అవును, ఏం చేస్తున్నాం మరి. సో ఇప్పుడు ఎలా వస్తుంది? ఇప్పుడు ఎలా వస్తుందమ్మా?
వినిపిస్తుంది సార్.
క్లియర్.
ఓకే, మీకు ఎప్పుడైనా నా వాయిస్ అది బ్రేక్ అయిపోయినా రాకపోయినా నాకు వెంటనే కాల్ చేయండి అంటున్నాను. ఓకేనా?
ఓకే సార్. ఓకే సార్.
ఓకే. సో drainage basin can be two types, rural, that is natural, and another one is the urban, man-made. Why rural? Bit disturbed, right? You see a village, they can construct houses at different without sometimes in Nalla, something like that. So any roads or buildings across a natural drain. Whereas in case urban drainage, urban, where piece of land is very costly, so what they do, they encroach into the natural drains, or sometimes they construct some public or you can construct a pole just middle of the drain, something like that. Okay, so that is the reason why the topography of the urban completely changed. Okay, so because of the change in the urban topography, so there is I mean all the natural drains will be I mean some it's because of this to the roads it will I mean encroach into the houses also. So this is the when you encroach into the natural drains, if rain occurs, the rainwater will encroach into the I mean houses on the roads. Okay, so if, I mean disturbance, I mean the deviation should be minimized. Okay, you have to maintain the natural boundaries so that if there is any rainfall, heavy rainfall occur, so the flood so the that it will encroach into the land, I mean on roads, on houses, or some properties, right? So these are two types of drainage system. Generally we talk. One is the rural drainage system and an urban drainage system. Okay. When it rains on the sea surface, 3 peak rate of flow increased by 8 times. Okay, so that is very important. If you see the hydrograph, so maybe the volume of water may be the same, but if the peak is comparatively less, then that is the I mean safest hydrograph I mean to pass through a drain. If your P is very high, so that is means in a short time, so you will have a heavy flow. So that cannot be accommodated by the drains provided either natural drains or man-made drains. So therefore overflow. So because of the impervious nature of the surface in the urban cities, either it may be a roads and parking slots or maybe a terraces or something else. So the infiltration losses will be very less and the evaporation is also very less. Okay, therefore runoff, velocity of runoff will be more. So that will cause to increase the peak in the hydrograph. So in general, so if there is for a same amount of rainfall, if it falls over the rural area, over the urban area, the hydrograph in the urban area 8 times more, I mean peak rate of hydrograph in the urban area 8 times the peak rate of hydrograph in the rural area. That is one observation. And then a shorter time of flow, 3 to 45 minutes, caused by increased velocity of runoff. Okay, so because of the impervious nature, the velocity will be more. Okay, I want the runoff volume increased by up to 6 times. If it is in an urban area, the runoff volume increased by up to 6 times, because the reason is that if it is the rural area, there is a very less impervious soil, so therefore it is more pervious, so therefore rainfall will meet the infiltration demand. Okay, most some amount of the rainfall will go as a go into the ground as a infiltration and it will reach to the groundwater, and some amount of rainfall also evaporate because more spacious area are more spacious, and even the vegetation will be more in case of a rural, so the vegetation also obstruct the rainfall, so therefore the losses will be more. So that's why the volume of water flowing over the surface is less in case of a rural area, but is in case of a urban area you will see very less vegetation, and all major land will be covered with the concrete. So therefore, the volume of runoff will be more in case of a urban, right? So that is 6 times more than the volume of water collected in the rural area for same amount of rainfall. Okay, the magnitude of such increase depends on many factors, such as frequency of storm and local climate and conditions of the catchment surface. Okay, so that depends upon the frequency of storm, local climate, and conditions of the catchment surface. Okay. The post-development runoff peak can be reduced by structural measures. So what is our objective is, so you have to decrease the peak runoff. You have to decrease the peak runoff, right? That is our objective. So what is the purpose of providing a flood control reservoir? If reservoir is not there, so the hydrograph will be, I mean, the peak of the hydrograph will be very high. Okay. So if your reservoir is there, so you can, store the flood water temporarily and release slowly. So therefore, you can reduce the peak. So once you reduce the peak, it cannot inundate the areas besides the rivers. Okay, because the peak is reduced, the river can carry so this flood water safely without the inundating the sides of the banks. Okay, so similarly in urban area also, so our objective is to decrease the runoff peak. So how you can decrease? There are some structural measures. Okay, they are physical in nature. That includes redesigning the existing drainage system. Okay, so if the drainage system is not adequate to, accommodate this peak, you have to redesign it. Okay, or providing suitable interventions in the form of storage at suitable locations in the upstream catchment. Okay, so some type of detention storage tanks can also be constructed at upper catchment. So therefore, the rainwater can be bypassed through into this detention tank. So temporarily the water it will be stored there. So like we have a boat club. Okay, if the rainwater is there, you can all drains you can design in a such a way that it will go into the boat club. Okay, so therefore you can store the rainwater in the boat club. If boat club is not there, what will happen? So the whole area will get inundated, right? So such type of measurements, structural measures can be taken up to decrease the peak flow. Okay, so non-structural measures. So the structural measures means some type of construction activities, redesigning the existing drainage system. Okay, or constructing the detention ponds, right, at different locations. Okay, so therefore you can store the storm water. Okay, and that can be used further or for any recreation purpose, something like that, right? So non-structural measures strive to keep people away from the flood water by means of early warning system and other mitigation measures, right? Non-structural, these are non-structural measures, right? What are the non-structural measures? So to keep away from the flood water by means of some early warning system and other mitigation measures. So can relocate the people where more inundation is taking place to a safer locations in order to avoid so many problems. Okay, if the flood water is there, sometimes it enters into the houses. Okay, and some maybe snakes and other danger species can also enter to the house. Okay, that leads to some other problems, right? So you can relocate the people residing in the area where possibility of flooding takes place into the safer locations. So these are comes under the non-structural measures, right? Drainage system. Okay, drainage system can be categorized as a major and minor systems, right? The major drainage system comprise of open nullas and natural surface drains. Okay, the major drain system are open nullas. I mean, పెద్ద కాలాలు ఉంటాయి కదా, that is a open nullas. Okay, so that is not completely covered, right? So only sides and bottom are you can covered with the concrete. Okay, and top is open. Okay, or some natural drain system. So these are called major drainage system, right? The minor system is the network of underground pipes or small channels. Okay, so these are called minor system, right? If you have a from home, you have a small channel. Okay, sometimes it may be a open, sometimes it may be a closed also. Okay, underground pipes, so these are called a minor system. So major system, minor system. So the minor system can be categorized in two types. One is a separate and another is a combined. Okay, separate means a separate drainage system consists of two conveyance network, the sanitary sewers conveying wastewater from homes and business to a discharge point. Okay, so a separate drainage system is one pipes are used to convey the sanitary and sewage water. Okay, that is collected from the home or from any business like hotels, shops, malls. That's right, and that is the separate. And there is a separate system for the storm water. Two network pipes are there in a city. One is used for the drainage purpose and another one is used for the storm water purpose, right? So that is the separate. Okay, storm drains collect water. The underground pipes are channels collect water from rainfall runoff and convey it to a discharge point, which is usually a natural water course or coastal waterways. Okay, so storm water drains, it may be underground pipe or canals, collect the water from the rainfall runoff, and where it will be discharged, it will be discharged at a place where if there is any natural water course is there, I mean some river is going on, so there you can discharge this drain water into the river or any coastal waters. So if there is a even you can discharge into the sea also. Okay, so but there is a standards are there before discharging even storm water or drain water. So you have to treat that water and ensure that the quality of the water come to a certain standard, and then you have to discharge the water into the rivers. Okay, you cannot discharge even wastewater just like that without treating that wastewater, right? But there is a standards. Okay? A stormwater drainage system inventory. Okay, there should be an inventory. See, first of all, if you want to take any decision, right, we should know have the data in your hand, right? So then only you can take any decision for a designing or anything for maintenance purpose or for something anything. First you should have an inventory. Inventory means what is the drainage map, okay, and their cross sections, okay, their slopes, okay, where pumping is taking place, where lifting is taking place, right, and where these detention ponds are there, right, where the natural drains are there, and contour maps. Also, all those things comes under the this drainage system inventory. Okay, so it is observed that proper inventory of water supply system is maintained, stating with the details of treatment, pumping, storage, and along the main feeder lines to the smallest domestic connections. Okay, so all those things, if we have a, if we have in your on your table in the form of digitally or manually. Okay, digitally means if you have digitized everything like using a GIS or remote sensing techniques. Okay, and then you can have a good decision making can be taken up using that data. Okay, similarly for the sewer line, an inventory is available starting from the smallest domestic connection to the sewer trunk mains for all the areas which are serviced with the proper sewage system. Okay, these are generally essential for operation and maintaining besides system upgrading and replacement, right? So if we have in your on your laptop the entire, say for example for our Kakinada drainage system, if you have everything is there, drainage network, natural drains, right? And you can simulate the system. Say for example today there is a warning is there over Kakinada, tomorrow there may be a, let us say 10 centimeter of rain may takes place within an hour. So if you give these two values, 10 centimeter duration is 1 hour. So there are models are there which can simulate. Okay, so if that things means that rainfall, that event occur over the area, so how the flow is in the pipes and where are the areas, inundated areas, everything can be simulated. Okay, and then you can give a warning to the people where they are living in an inundated area. Okay, such type of facility is also there. Okay, latest techniques can be used. Municipal authority generally do not keep a systematic and completely inventory. So especially of the minor drainage system, as a result of this, it is difficult to plan operation and maintenance and upgradation of the system. So that is true. So generally, if you go and ask for any data, drainage data, so they don't have, they are not maintaining the drainage, this inventory. So they can give you a major pipes or major drains, so they don't have a minor drains, right? So they don't have minor drains in the form of either GIS format or on a map. Okay. Otherwise, if they have, though they have, they are not unable to utilize those inventory also because they are not trained. Okay. So that is a major problem. Generally, any municipality, authority will face while doing some operation and maintenance or upgradation of the system, right? Even with respect to the major drains, inventories are not maintained with clear delineation, demarcation, and the detail of cross section and slopes, right? So if you have a drainage system, so when drain is there, so from you have to demarcate the area for that drain. Say that like a catchment, you know how to demarcate the catchment. So what is the catchment is it collects the water and drained off through a single outlet. Okay. So how do you demarcate the drainage system? Catchment. If you have a contour map, so you can draw on the edges. Okay. So then, so that is the catchment. So if you have the outlet point, from that you can demarcate the outlet point. So that is that means that, so if you draw an outlet, draw a ridge line, so within the ridge line, so that will pass through in that catchment. Outside the ridge line, so the catchment is different. Okay. So if you have a pipe is there, okay, if you have a pipe is there, so you have to demarcate the area from where water will come into this drainage system. Okay. So there may be a natural formation and man-made structures like bridges, piers, transmission towers, and cables laid across service utility like sewer, water supply, and gas pipelines, which may reduce the cross section of flow. Okay, so that is the, as I said earlier. So by constructing bridge piers and transmission towers and cable laid across service utilities like sewer, water supply, gas pipelines. In general, what they do. So because these natural drains are nobody land, it is a government land. So in general, they construct these type of structures in natural drains. Okay, so therefore you can save the money. Otherwise, they have to buy the land to construct a bridge pier if it is a comes under a private land, right? So because of these structures, the cross section of the natural drains reduces, isn't it? So because if cross section reduces means the carrying capacity of the water of that nalla is reducing. Okay, so because of that also flooding takes place nearby the areas, right? So this is the one reason why flooding takes place in near when the flood takes place over the town. Okay, besides all these, there may be an existing encroachment, etc. An inventory of the existing stormwater drainage system will be prepared on a GIS platform. Okay. Now, GIS, Geographical Information System, is there. It is there. Okay. So you can easily, digitize everything, which is spatially connection. Like a drainage system has a spatial connection, right? So those things can be easily digitized using any GIS platform. There are a number of GIS softwares are there. So you can use any GIS and prepare an inventory of the drainage system of an entire town. Okay, that inventory will be both watershed based to enable proper hydrologic and hydraulic analysis, and ward-based to enable coordinate administrative management. Okay, so the inventory will be both watershed-based to enable proper hydrologic and hydraulic analysis. Right? This inventory, as I said, the boundary of the inventory is not the political boundary. As I said, okay, it means that suppose if there is any drainage is there in ward number 1. Ward number 1, there is a drainage is there. Okay, it doesn't mean the water falling on the ward number 1 will come to this drainage. Okay, right? So it follows only natural boundary. If the natural boundary falls in the ward number 2 also, means the water collected from ward number 2 will also come to this drain, which is located in the drain number ward number 1. Okay, so what I am trying to say is that all analysis, hydrological analysis, can be taken up on a natural boundary, right? So it means that suppose you want to do a modeling, rainfall runoff modeling for a Krishna basin. So you have to consider the entire Krishna basin. Okay, entire Krishna basin, right? Say, for example, if you want to do this modeling in Dhavaleshwaram, okay? So Dhavaleshwaram, from Dhavaleshwaram to upper catchment, upside, full entire Godavari basin you have to consider. Okay? So because even the rain occurred at Nasik, okay? That water will reach to the Dhavaleshwaram after some days or some hours. Okay, so and why I am stressing this is your senior one student has come to me. She told me she want to do rainfall runoff modeling at Dhavaleshwaram basin. Then I asked, okay, you show me on a map. Okay, how do you do? Okay, so then I asked from rainfall data, show me the location of the rainfall data. And she doesn't know that. She said that only the rainfall falling near Dhavaleshwaram will be used for the analysis. No, not because the rain falling on the Dhavaleshwaram and Nasik will also reach to Dhavaleshwaram. Okay, the rain falling on some part of Telangana will also come to the Dhavaleshwaram. Similarly, the rain falling on some part of Karnataka will also come to the Dhavaleshwaram. Similarly, the rain falling on part of Maharashtra will also come to the Dhavaleshwaram. Similarly, rain falling on part of Orissa will also come to the Dhavaleshwaram. Similarly, rain falling on part of Chhattisgarh will also come to the Dhavaleshwaram. So the drainage basin of the entire Godavari, okay, you have to consider, because you are taking a point at just the end of the basin. Okay, depending upon the basin, your boundary will be demarcated, right? So therefore, here also the inventory says, for example, Kakinada city is there, comes under a basin. Okay, so the entire basin you have to demarcate the natural drains. So the water falling on that basin, so it may not the city limits, that will also come to the Kakinada city, because it follows the nature. The water follows the nature. Okay, water flow takes place from the higher elevation to the lower elevation. Okay, so the water will always move from higher elevation to the lower elevation, right? So instead of your political boundary, you have to consider the natural boundary, right? So that is what I am trying to say, right? The minor system should be made mapped clearly, showing the interconnection with the major system, besides the cross connection with the sewer lines. Okay, a minor system should be mapped clearly, showing the interconnections with the major system, beside the cross connections with the sewer lines. So everything, okay, I mean, from the major sewer to the minor sewer, or any cross section, everything with the diameter of the pipe and the slope of the pipe. Okay, if the drainage system is underground, so every parameters, I mean, every property of that drainage system should be captured. Okay, so that is maybe spatial data as well as tabular data. Okay, spatial data means if it has a location, latitude, longitude, that is called spatial data. So the property of the sewer system, like diameter, and that is when it was constructed. Okay, what is the length, I mean slope. So all those things are tabular data. Okay, so major system will be mapped clearly with delineation. Okay, demarcation and details of the cross section, slopes, drain, crossing, including natural formation and man-made structures like bridge, pier, transmission towers, service utilities, and existing encroachment. So they should also taken into account the sewer discharge, right? So this is also you should map, right? And a requirement for urban drainage design. Okay, there is a need for the development of an adequate and functioning drainage system. So based on the sound hydrological and hydraulic design principle, so you have to develop an adequate and functioning of drainage system. Okay, so you cannot design just like that. Okay, there are you have to follow the hydrological principles, right? Hydrological principles means, say, for example, okay, runoff is depending upon the infiltration. It depends upon the intensity of the rainfall. It depends upon the time of concentration. So all the principles, right, you have to keep in mind, and then calculate the runoff, and for the runoff you have to design your drainage system. Okay, similarly hydraulic principles. So hydraulic principles means what is the velocity of drainage water in the pipe, whether it is a open channel or closed pipe. Then what is the pressure at different elevations? Okay, what is the velocity? Okay, all those things, that is our hydraulic principles, right? So both hydrologic and hydraulic design principles should be keep in mind while designing the drainage system. The design of an urban drainage system requires knowledge of the catchment area and topography, urbanization details, rainfall intensity, hydrology, hydrology. Okay, so for designing urban drainage system, we should have a thorough knowledge of the catchment area. Okay, of at particular location, how the catchment area is look like, right? And the topography in the sense what is the contours, right? Elevations of your catchment, right? And urbanization details. Okay, urbanization details means land use, land cover, where is the pavements are there, where is the pervious soil is, where is impervious soil, where is the vegetation is there. Okay, so all those things, urbanization details. And rainfall intensity, so you have to study the last 40-50 years rainfall data. Okay, as I said in last class, intensity, duration, frequency curves, so that also be studied. And hydrology, and hydrology means all this rainfall, and then temperature, and infiltration, evaporation, so all those things, and groundwater levels in that area. Okay, and hydraulic data. Hydraulic data means what is the if it is a open channel, what is the rugosity coefficient, surface roughness of the drainage system. So all those things, so you should have a thorough knowledge. So then you can easily design the urban drainage system, right? Catchment has a basis for design. Okay, as I said earlier, catchment is the base for design, not the political boundary, not the, say for example, you are designing Kakinada. So Kakinada boundaries. So like we have a like assembly for Kakinada urban, Kakinada rural, right? So those are political boundaries, not natural boundaries. Okay, so any analysis should be done on the natural boundaries, not on the political boundaries. So therefore, catchment as basis for drainage, for design, right? States and cities have political and administration boundaries. However, rainfall and runoff process are independent of these and depend on the watershed delineations. Okay, so the rainfall does not know political boundaries. It only knows only the natural boundaries, and it will follow only natural boundaries, right? So each urban area may consist of a number of watersheds. Okay, so you don't know this. If there is a big cities are there like Mumbai, so it may fall on different watersheds. Okay, right? So are some few small towns also comes under one watershed. Okay, so that depends upon the size of the urban. It may falls in a different number of watersheds. Okay, or number of towns may fall in watershed also. Okay. Watershed is the geographical region within which water drains into a stream, river, lake, or sea. That is the definition of the watershed. What is the watershed? Is the geographic region within which water drains into a stream, river, lake, or sea. There is a single outlet. Okay, all the collected rainwater will pass through a single outlet. So that is called watershed. The watershed may be composed of several sub-watershed and catchment. Okay, so that's obviously if watershed is there. So, say for example, if you see, look at Godavari Basin. Godavari Basin has so many tributaries. So one is Indravati River. So Indravati River comes from Varisa, Chhattisgarh, okay, and it will join the Godavari, right, somewhere. So if you consider the joining point Godavari and Indravati as the outlet, so that is sub-basin of Godavari. Indravati is a subcatchment of the Indra Godavari catchment, right? So like that, okay, there will be another tributary, okay, so that has separate catchment, so that will join the main Godavari river, right? So like that, this is the sub catchment. Contour data. So this is also very important. Accurate contours are necessary for determining the boundary of watershed catchment and for computing direction of flow. Okay, if you have the contour data, you can, simulate how the drain water move. Okay, so the principle is it move from higher elevation to the lower elevations, right? Detailed contour map at required resolution should be prepared for proper delineation of drainage catchment. Okay, so detailed contour map should be prepared. Okay, already it's say there are, for example, the map of the city at the interval of 0.2 meter, while Chennai is preparing for 0.3 meter. Okay, so similarly, if you have a contour map for Kakinada, then so it is easy to, it will be very useful for designing the drainage system. Okay, I will stop here. Okay. Hello.
Sir.
ఆపేస్తాను.
Okay, sir.